Hello everyone. My name is Ricardo. I'm a first year graduate student here in UASI. I'm a mine engineer, so that's my background. I have no previous experience with space engineering, space science, and today I'm here my first time participating in the space symposium because I'm taking Dr. Tenorio class, and he encouraged me to come here and present one of our class projects for you guys. So without further ado, Luna mining, overcoming challenges and evaluating excavation strategies. So first of all, why mine on the moon? And well, there are several reasons, but I would like to highlight three of them. First, we can extract some mineral resources from there. And I'm talking about iron, aluminum, and other metals. We can also talk about helium-3. We haven't talked about that so far, but that's another interesting approach to the moon mining. And the third one is the water ice that can be found in the moon holes, right? I don't want to be repetitive because we've been talking about some of these stuff so far, but well, here we have a sample of one of the Apollo's mission, and as you can see, we can find some very high content of iron and aluminum, among other metals. And on the right here, we have a picture of the moon regolith, which is actually unconsolidated rock fragments. But it ranges from fine dust until large boulders. And here on the all the way to the right, we have the South Pole, where there is evidence of water content in these craters. So I just want to highlight that before we move on. And this is a prototype from NASA, actually, and they are working the ISRU pilot excavator. And well, by the way, I tried to put as many visuals as possible in this presentation because that's not highly technical, but I want to make it engaging. And well, it's kind of hard to find a concept that is, a silver bullet, because it's very challenging to have an excavation on the moon. So what I don't like about, personally speaking, as a mine engineer, what I don't like about this approach is the fact that it can handle well fine particles, but if you come across any kind of big rock or boulder, it becomes a problem, right? An issue. So for this presentation, I'm trying to come up with some requirements that I believe a machine should have in order to dig on the moon. And I'm going to talk about the actuation system, sizing strategy, mobility strategy, and simplicity in operation. Again, we talked about that, right? Right before. So hydraulics, they with the extreme temperatures, they will become a gel, so it's not suitable for that purpose. Pneumatic, we have the problematic issue with the gas leakage that cannot be solved on the backing. And for that feature, I would go with poly and cables because they can be they rely on electric motors, and they have fewer failure points. And now let's talk about sizing. Well, first of all, here on Earth, when we think about mining, we usually tend to go bigger because it's more efficient. So from my perspective, I believe that we should aim for big equipments on the moon if you want to speed up the process of the mining and make it feasible. And Well, right now we know that SpaceX is developing the Starship program, and currently the cargo capacity is around 100 tons. So going back to Earth, this is an excavator, which the operating weight is around 100 tons, just for us to have a comparison. But the problem is when you try to fit that equipment inside the Starship, as you can see on picture A, that's not going to work, right? So that's why I believe that we should have a strategy that can come from weightless ship, right? We need to either make the equipment foldable, or we should have an equipment that can be easily assembled on the moon. I think I will skip to the next slide. Sorry if you guys are curious to see the entire footage. So that's a sketch that I have with putting everything together, So the idea is to have a foldable drag line that can, once it is assembled, it will reach the same size as the excavator that we saw in one of the previous slides. And when we fold that, we can actually fit it into the Starship space, right? Or area, I don't know. And there's one more thing that I would like to add to my concept, which is the mobility strategy. When we think about a larger equipment, we're gonna need more wheels. But more wheels means more bearings, and more bearings with the regolith, the dust from the lunar regolith can be a challenge, right? So wheels, no, because of that reason that I just explained. Tracks, even here on Earth, tracks are highly demanding in terms of maintenance. So I wouldn't go for tracks, which lead us to the feed system that we can see here with this drag line navigating across the mine. And finally, we can get to the operation aspect and future of that presentation. And here I'm showing you how a drag line works. And as you can see, a drag line is very efficient, not only in digging, but it can actually, because it has a very kind of standard reach, it can pile the material far away from the digging area. So yeah, so talking about what is that? Benefits of a larger excavation. So we're talking about increased payload capacity, reduced cycle times, enhanced force leverage, higher reaction force generated, and improved digging and lifting performance. And well, and this is just my takeaways. A drag line is a viable solution for lunar excavation, according to what I present so far. And it is capable of heavy-duty performance, extreme conditions, terrain adaptability, and vertical excavation. And with this, that's all that I have for today. I appreciate your time and your attention. So yeah, questions? And by the way, there's a question there. I just want to give a short note. Because of my lack of knowledge about space engineering, if anyone in the audience wants to help me to answer the question, you're welcome. But okay, go ahead.
I'm curious, so in your evaluation of what type of technology to use or would be suitable, did you take into consideration the environment on the surface of the moon that's really dusty and very staticky, where the dust gets on everything and we get into bearings and sees the bearings up? So drag lines could be problematic unless you deal with sealed systems.
Interesting. like I said, in one of these slides, it's very hard to find, the silver bullet that covers all the, problems that we can find in the moon. That's a very interesting approach. No, I don't have like the best sense for that. If the dragon line will overcome that kind of challenge, I still need to, look into that problem that I brought, in a deeper, way, but, I appreciate it. Anyone want to do that?
What's your plans for power in your system?
Like that?
What's your plans for power? Can you going with an electric vehicle?
Yeah, it must be electrical.
So how heavy is the whole thing?
That's a good point, I didn't get to that part, but it can come for the next, presentation. Oh, so many questions. Oh,
I was gonna suggest, we also looked at the same problems, particularly from a heavy construction point of view. And I think a viable path forward is to look into spider cranes. Yes.
Oh, okay.
So these are cranes that are legged, as we spoke, has that advantage. In fact, seal a lot of their internal components out.
Well,
But I would say addressing the, big cable line issue is it can distribute its mass.
okay.
And further, you can connect multiple vehicles together. This will give you some of the advantages, so.
Interesting. Very good.
Happy to chat also.
Oh, awesome.
All right,